Till now we have understood that carbon forms the covalent bonds. In the organic compounds, covalent bonds are found. And then again these covalent bonds are of two types, sigma bond and the pi bond. So in this video, I am going to cover what are the sigma and what are the pi bonds in organic molecules. So in covalent bond, there is a overlapping of an atomic orbital of one atom with the atomic orbital of another atom. So in this way, they share their electrons with each other. And this overlapping is also of two types. First is the end-to-end overlapping. So this end-to-end overlapping results in the sigma bond. So this can be SS, overlapping between the s orbital of the two atoms. It can be SPX also. So first let me explain this. This is the s orbital of one atom and s orbital of another atom. So overlapping between the two s orbitals is the SS overlapping. And then next is the overlapping between the s orbital of one atom and the px orbital of the another atom. So this is also, we can see here, this is the end-to-end overlapping. This is the end-to-end overlapping. So this is called the SPX overlapping. And it can also be overlapping between the px orbital of one atom with the px orbital of another atom, end-to-end overlapping. So this is also the sigma bond. So we can say that this sigma bond can be formed by SS overlapping, SPX overlapping, or PX and PX overlapping. So all these are the end-to-end overlapping, and it results in the formation of sigma bond. So the second type of overlapping is sidewise or parallel overlapping. So this sidewise or parallel overlapping results in the formation of pi bond. So here we can see this, when the parallel overlapping takes place between the atomic orbitals of the p orbital of one atom with the p orbital of the another atom, like this. So again I can draw here. This is the p orbital of one atom and sidewise overlapping in this way. So this is the sidewise overlapping or parallel overlapping. So this is called the pi bond and PP overlapping. So we have understood that two types of bonds are there, sigma bond and pi bond. So now now we can study about what is the difference between the sigma and pi bond. So this is sigma bond, pi bond. So first difference is sigma bond is formed by end-to-end overlap of atomic orbitals. So just now we have discussed this. And this pi bond is formed by lateral overlap of p orbitals. Second is only one sigma bond can exist between two atoms. Only one sigma bond can be formed between two atoms, but in case of pi bonds, it can be one or more than one, two pi bonds. So one or two pi bonds can exist between two atoms. So next is sigma bonds are directional. and geometry of molecule depend on the sigma bonds. So as we have discussed in the case of methane, okay, how in methane it is having the tetrahedral structure because it is all the four hydrogen atoms are directed towards the four corners of the tetrahedron, and methane molecule has only sigma bonds. So sigma bonds are directional and the geometry of the molecule depends on the sigma bonds. Pi bonds are non-directional and geometry of molecules does not depend on pi bonds. So fourth is area of overlapping is higher and hence sigma bond is always stronger, and pi bond area of overlapping is small and pi bond is always weaker. So just now we have studied it. Okay, in case of sigma bond we can see end-to-end overlapping. So overlapping area is higher. Overlapping area is higher, and that is why sigma bond is always a stronger bond. And in this pi bond, overlapping area is very small, and that is why these are the weak bonds. These are the weak bonds, and sigma bonds are the strong bonds. So next, fifth is has free rotation, and in case of sigma bonds and in case of pi bonds there is no free rotation about C double bond C bond because this is a weak bond we have discussed just now, so it does not permit the free rotation about C double bond C. Sixth is has cylindrical charge symmetry about bond axis. And in this case, so first let me explain this, has cylindrical charge symmetry about bond axis because it is the end-to-end overlapping. So these electrons have the cylindrical charge symmetry about the bond axis. But in case of pi bond, electron cloud of pi bond is located above and below the plane of bonding atoms. So it is like this. With this example we can understand this. This is the ethene molecule. So I have drawn the configuration of this molecule ethene. So these are the two carbon atoms, and we know between these two carbon atoms double bond is there, and these are the four hydrogen atoms. So this pi bond, so see between these two carbon atoms there is a double bond, and in this one is the sigma and another one is the pi. So this is the sigma bond and this is the pi bond. So this is only one pi bond, and for the pi bond, as it is said, electron cloud of the pi bond is located above and below the plane of bonding atoms. So this electron cloud is above and below the plane of bonding atoms, and these electrons in the pi bond are easily available to the attacking reagents. So we can say that these pi bonds are the reactive centers in the organic compounds because they are also the weak bonds. No? So this is all about the sigma and the pi bond. So after this there is a very important topic about if any particular molecule is given, how to find out about how many sigma bonds, how many pi bonds are there, and also about the hybridization of the carbon atom in the organic molecule. So thank you so much.